Hello everyone, welcome back to my channel, The Quant Tutor. Today we'll be doing question number 5 of P1 Jan 2022 paper. Alright, so the first question gives us a nice figure of a semicircle. We have some details of this circle which are the center, the diameter, and the radius, which is 3 meters. Right, the question then follows on and says that the straight line is parallel to AE, BD is parallel to AE, and the angle BOA is 0.7. So let's draw this to make sure that we've understood this. So this is 0.7, right? Radians. Okay, my drawing is not the smoothest, but I hope you can bear with me. All right, so now part A says that show that to four significant figures, angle BOD is 1.742. All right, so I'm going to draw a replica of this semicircle that we have, right? Okay, let's say that we have this is BD, right? And this is AE, and we know that this is O, right? Now, so what we know that BOA is 0.7, right? Now, and we want to find BOD, right? So this is what we want to find. We want to find this. We know 0.7 here. Now, because O is at the center of the semicircle, right, that essentially means that the distance BD it will be equal to the distance, BO will be equal to the distance DO, right? So what this means is that this will also be 0.7. And if this is 0.7, right, and we know that in a semicircle, the angle here is pi, right? So what we will have to do is x will basically be pi minus 0.7 minus 0.7, right? So that's pi minus, so that's basically 3.142 minus 1.4, which will basically give us 1.742 radians, right? Exactly what we need. So this is a nice simple 1 mark question, and I hope you all understand this. Now let's move on to part B. So part B introduces us to the flower bed R, right? So we have, this is our flower bed, and it's bounded by BD. So it's bounded by BD, it's bound and the arc BCD. Okay. And now our objective here is to find the area of the flower bed, giving your answer in square meters to 1 decimal place. All right. So what we have to do here is that we've been given the angle BOD, right? So okay, so let's draw this arc, right? Let's draw this sector here. Okay, but don't just please forgive my drawing. Okay, so this here is 1.742 radians, right? Right. Okay, and now we are asked to find this area. Okay, now the way that we can find this, and I'm sure you've learned this in your textbooks or in your classes, that there's actually a formula, one nice formula that solves this problem, right? Which is the formula of this part of an arc, right? The top area of an arc, which is half r squared theta minus sine theta. However, I don't want you to just memorize what this formula is, right? Or just remember this formula. What if you break down this formula? What you will see is that this formula is actually doing a very simple thing, right? So what this formula is doing is it's taking this equation, right? So this equation here is essentially the area of the whole, it's the area of the whole arc, okay? It's this whole area, right? It's taking this whole area and then it's subtracting that by half r square sine theta. which is only the area of the triangle, right? So if you take the whole thing, the whole area, and you subtract the area of the triangle, then what you will be left is this blue color here, this region R that you are trying to find, right? So basically, this is the area of sector, and this one is area of triangle. Okay, so the reason I'm telling you this is because yes, it's very useful to remember this formula, right? But if a question comes in a different way, right? Let's say that you need to find only the area of the triangle, right? Then what do? Right? So it's always important to understand how these equations come about so that if there are trickier questions here and there, you will be able to adapt and answer these questions. All right? But now since we already have the equation, let's use the equation to find the answer. So A now is going to be equals to half r squared. We know that our r is 3 squared. Our theta is 1.742 minus sine 1.742 as well, right? Theta is the same theta. But now remember, okay, don't forget to change your calculators to radians because sine of 1.742 in degrees is very different to that of radians. Yeah. So make sure you have your calculators in place. And if you basically solve this question, you will, if you solve this equation, what you will get is 3.4 meters squared. All right. So that seems good. I hope you understand this. If there's any questions or anything, feel free to post it in the comment. All right. And finally, let's go on to part C, right? So part C tells us to find the perimeter of the flower bed, right? Also giving your answer to one decimal place, right? So let me just draw the whole semicircle here again. Okay, so this is B, D, and I say, please forgive my drawing. This is O, A, and E. All right. Now, our objective here is to find the perimeter of the R, right? Which is, I would need to find BD, right? I need to find the length BD, and I need to find the arc length BCD, right? So, arc length BCD, right? So, these are the two things. If I can find the perimeter of the flower bed. Now, let's start with the length. Let's start with the arc length BCD because I think that that's a lot simpler. Right, so if we look at the arc length of this, what you know is that I need to find the circumference, right? It's basically finding the circumference. The circumference of a normal circle will be 2 pi r. I'm sure you all have learned this at some point in your mathematics syllabus, right? So 2 pi r is the perimeter of a normal area, of a normal circle, right? But now we want a sector of a circle, right? We just want a fraction, right? A fraction of 2 pi. We know that this whole thing is 2 pi, right? The whole angle is 360 degrees, which is 2 pi radians. We want a fraction of that, right? So essentially what we want is, we want just theta over 2 pi of 2 pi r, right? And if I cut 2 pi and 2 pi, what I'm going to be left with is theta r. And I'm sure this equation is so familiar to you, right? Theta r, which is the arc length. And this is how it comes about, right? So theta r, now we have all the information that we need. Our theta is this theta that we are talking about, right, which is 1.742. Multiply that by the radius and we get 5.226. Okay, I'm going to erase this part here. I'm going to erase this circle here, and I'm going to take this working a little bit up so that we have some space to other things. Okay, so let's take this So now we know that we're going to do BD later, right? So let's get the BD here first. Let's get the BCD up here. Perfect. This looks good. Now let's look at the BD, right? So now for BD, what we essentially need to do is that we need to find this length, right? We need to find this length as drawn earlier. Now let's see how we can break it down. We know that this is an O. This is O, which means it's the center of the semicircle. So if I draw a line that goes down like that, I know that I'll break these two into half, right? So this will be X and this will be another X. They'll be of same value, right? Okay, let's say that this is Y and this is Y, okay? Now, in order to find this, I also, if this length here is the same as this length, right? Because this essentially becomes like a square, right? Because this point and this point is the same length, and this point and this point is the same length. And I can do the same thing here. And the beauty of this question is I already have this angle here, which is 0.7, right? So I just need to use basic Pythagoras theorem to find this length, right? Which basically is this length. And then once I get this length, I just have to multiply by 2 to be able to get the whole BD. Okay. So what I'm going to do is I'm going to find this length first. Okay, this X length here. Let me clean up this. So I'm going to find X. Okay. So X here, and I know that this is 0.7, right? So cos theta, and also I know that this is 3 meters. And right, because that's the radius. So this radius here is 3 meters. So cos theta will be equals to adjacent over hypotenuse, right? So our cos here is 0.7 is equals to adjacent. Adjacent is our x, which is what we are trying to find. And our hypotenuse is 3, right? So if I do 3x is equals to 3 cos 0.7, which is essentially equals to, so if I quickly put that into my calculator, 3 cos 0.7, and I will get 2.295. 2.295, right? And as I mentioned, BD will be equals to 2 multiplied by 2.295 because we got this length, right? We got this length, and now we multiply this length by 2 to get this whole length, right? So this answer will be 4.49, about 4.49, right? And now what we need to do is that we need to add both of these, right? So we need to add BD plus BCD, right? And we know that our BD is 4.49 and we know that our BCD is 5.226. Let me just put a box around them so you can all identify the answers, right? Plus 5.226, and this is going to give us 9.8 meters in 1 decimal place. Perfect, right? So now we have completed this whole question. If there's anything that you find confusing or anything that is not clear, feel free to comment your questions in the comment box below, and I'll be happy to explain anything you need. Please don't forget to like and subscribe this video, and I'll see you in the next one.